Hello everyone, welcome to day 11 of our machine learning masterclass internship. And in this session, we'll be discussing about the basics of our machine learning concepts. And we need to understand some terminologies also, like features versus target, what is called as a feature, what is target, and what are the types of machine learning, how is the workflow is going to be, and then how we are practically going to use some libraries like scikit-learn and go and proceed with further steps like scaling, encoding, etc. So we'll be having scaling and encoding in this session, and in the next session we'll be having the other stuffs like handling null values with our scikit-learn library, and then moving towards outlier detection, etc. We'll see that later. So we'll start with features versus target. So previously we have seen a lot data set for examples, right, for exploratory data analysis. From Kaggle, etc. we have downloaded some data sets and we are exploring that. So if you discuss about that data set, then you want to understand what is a feature and what is a target. Okay. Before that, you also need to understand what we are going to do in a machine learning project. So to do that, you need to understand the types of machine learning, starting with supervised learning. So in supervised learning, you have labels, okay, and you have a data. This is a label. So you will be mapping it. Your algorithm will mapping it and give you, it will train on it. So if you give a new data, so it should map to the labels and then give you an output based on what it has learned. Okay, and yeah, in supervised learning we have two types. One is classification, one is regression. So this will comes under classification because in either of these three it is going to select one as the output. Or in regression, what will happen is you will be having a range of values like this, or core data, the sales value, present price, or etc. These values or regression values which are continuous values. So you will be predicting a particular value based on your x and y features. And you can see, so this is a categorical output, this is a continuous output because this value changes and this is going to be either this or that. So that will comes under the supervised learning. And in unsupervised learning we don't have any labels, so based on the difference we'll try to club together. And in reinforcement learning, so we will be having an agent and an environment. For every action there will be a reward will be given to the agent, so based on the value it will try to increase its efficiency. Okay, so yeah, that's it about the types of machine learning. So talking about this, in supervised learning, see here we have labeled the data and labels also, right? So this is the output. So your data which you have, right, so it is called as features. For example, what is the diameter here, what is the shape, what is the sharp edge. Okay, these details are called as features, and you have a label, right, which is called a circle or square or triangle, that is a target. And talking about here, for example, if you have a data set for regression, like what is the temperature going to be tomorrow, so you will be having the past 100 days temperature list. So there will be a temperature column which you are going to predict, and that will be a target. And talking about features, you will be having like what is the humidity value, what is the humidity present in the atmosphere, in air temperature, etc., something like that. Other details are called as features, and the thing you are going to predict or decide will be target, and which has label is also a target. So talking about that, you will be having multiple features. You can have a single feature or multiple features which are related in any way with this target. Okay, so what will happen is this algorithm which we are having is nothing but statistical tools. They perform statistics, and based on that they are going to give you the result. So they used to find the correlation between the features. So if this is the feature, if this is the feature, then the target is this one. If this is the feature and this is another feature, then the target is going to be a different. So like that we used to have features and target. So when we give it to our machine learning algorithm, we will be separating our features and target in different variables and then pass it separately. Commonly they used to do is in X, they'll create a variable called as X and they'll store all the features there without the target column, and in Y they will be storing only the target column, and both of this will be given to our machine learning algorithm. So you need to pass both X and Y values. And if I want to give you some practical example about a data set, I'll upload the data set and show you. For example, let us open this diabetes data set, and also we'll upload our Titanic data set. So I'll import pandas as pd, import numpy as np. We'll go with this for now, and data equal to pd dot read underscore csv, diabetes dot csv, data dot head. And this can show you are having a lot of column names, right? So you have pregnancies, glucose level, blood pressure, skin thickness, insulin, BMI, diabetes pedigree function, age. That is fine. Finally, you have outcome column, which is 1 or 0, which means the patient is having diabetes or not. Okay. So here we are having a lot of features here. So these are all called as features, and this is the target variable which you are going to map later. So this will be your prediction. So that is what, and these things will determine. So based on statistics, your algorithm going to map all these values and decide if these are the range of values, then what will be the outcome. Either yes or no will be decided at that part. You can also have other data sets like titanic.csv. So in Titanic dataset, your task is to find whether the whether the passenger has survived or not, right? So you have a survived column. So remaining things will come under their features. And also when we talk about the pre-processing, we will be doing something known as feature selection. For example, we know that survived is the target column. Fine. The rest of the things are features. And this feature should be important and correlated to the survived, whether they will be surviving or not. So if you talk about that, whether the passenger class decides the passenger survived or not, if you ask the question, I will tell yes. Okay. So mostly first class passenger has survived a lot. They have boarded first, and the third class passenger survived least. And also if you talk about sex, whether it will determine whether they have survived or not, means yes, because here females were boarded first and then they were mostly safe, and many of the male has lost their life according to this data set. And also age will also be an important factor, like children's has given first priority. So these are some of the things which determines, okay, whether they have survived or not based on what happened really. But if you talk about the name, can name be anything with whether they have survived or not? Okay, will their name be anything? Will it be a factor in deciding that? No, right? And also talking about passenger ID. So here the passenger ID is just a unique number for every passenger, and it can't decide whether a passenger has survived or not. So we will be selecting only the important features which is correlevant or related with the target. So that will also come into the next part. Okay, so not only this, you can have your, I'll go with the car data. And you can see the target we are going to predict is selling price. So based on these features, whether if it's a fuel type, what is a kilometers driven, what is going to be the selling price. It's a continuous value, it's a regression problem. Here this is target and remaining things are features, and we will select important features if car name is a deciding factor, because some has craze for the car names, right? For example, if I talk about BMW or Benz, then it has some kind of high value. It is that mindset is available with the people, right? So car name may be important in this factor. So you need to have the domain knowledge also before proceeding further. So that's all about features and target. So continuing with that, we are going to start with our next set of processes in machine learning. It's going to be common once you've done your basic process, okay, with Pandas Library and exploratory data analysis with Matplotlib, Seaborn, etc. Then what will happen is you need to proceed through processing tools, okay, and this processing tools we can have from scikit-learn, Sklearn library. And then we'll be going with feature selection. Okay, in pre-processing we have a lot of things to consider. We'll be doing it with our Sklearn library, which is for machine learning. And after that we'll be going with feature selection, which we have discussed just now. And we will be going with train test split to split our entire data set into partitions, so that we can have something for training and some part for testing its efficiency. And then we'll choose algorithms and go with model evaluation, and then choose different algorithms or different pre-processing steps, etc. To all these steps we need a machine learning library to proceed further, which is scikit-learn. which makes a lot of things simple. We'll see that. So talking about scikit-learn, also known as Sklearn, is a popular open source machine learning library in Python that provides a wide range of tools for data analysis, modeling and evaluation. And Sklearn is built on top of NumPy, SciPy and Matplotlib and supports integration with Pandas, which makes it easier to work in data science, or if it's data science then obviously the tool is going to be machine learning workflow. And Sklearn is also widely used in data science, machine learning, AI community for various applications such as predictive modeling or NLP or computer vision, time series forecasting, etc. So if you want to install this library, you can go with pip install scikit-learn. Please note it down, or you can also search in browser. You will be getting in the pip command. And you can import. Actually, this Sklearn library is actually a set of lot of packages and modules inside. It's a huge and vast library. We cannot directly import. We won't be doing like import Sklearn and then calling and using it. You can do, but what's the workflow is, whenever you require some module, so we will be calling from sklearn.preprocessing, take this, or from this you have to take this alone from Sklearn. That's how we'll be calling individual tools and using it. So going with the first one, see here, this are all going to be the next few steps which we will be following in the next few sessions. Starting with the pre-processing tools, we are going to converge into the pre-processing tools. In pre-processing, we need to consider 4 criteria. One is feature scaling, next one is feature encoding, next one is imputing null values, and next one is outlier detection and outlier handling. Okay, so I'll explain deeply once again. Talking about feature scaling, see here guys, everything will come in the name of feature, etc. That's why we have given an introduction of what is feature and what is a target. Talking about features, you will be leaving the target and then you will be taking care into the features alone. And when you talk about the features, what we used to do is, we'll be having these features, right? We'll be scaling it. Okay, before we have seen something in the similar name, which is feature selection, where we are selecting features. Here it is feature scaling, where we are going to scale the features, and later we'll be also going through feature extraction, where we'll be extracting features. So remember the term feature. So we'll be seeing about feature scaling, then encoding, then imputing null values. We have seen with pandas, you need to know how to find a null value. You can fill that null value or drop that null value, and if you are filling, you will be basically going with pandas. If you have went with pandas, then you will just take a mean value and replace it, or median value, or a value which you consider good, you will be replacing it. But here you can use Sklearn and use algorithms even to impute the null values, which sometimes works really well. We'll see that. And outliers, data points which are irrelevant with a set of groups, we can find it, detect it and handle it in this pre-processing. So in this session we will be seeing about feature scaling and encoding, and next session we'll be having imputing null values and outlier detection and handling. So let's get started. Starting with feature scaling. Okay, feature scaling. So what is it, feature scaling, and why it is important? Feature scaling is a method used to normalize the range of features of a data. Okay, so feature scaling has some methods like normalization or standardization, and it helps to avoid bias in machine learning model. So why we should do it, what is the importance of it, I'll tell you with a simple example. You are having a data set, right? For example, we are having a diabetes data set which has lot of columns, lot of numerical columns. And once again, if you have an algorithm, you need to give a data which is numerical only. Okay, you cannot have text in it. That's why we'll do encoding, which we are going to see next. Talking about scaling, if you are having numerical features in your data, okay, continuous values, like what it can be. See here, continuous value, year, selling price, present price, kilometers driven, or if you talk about your diabetes data set, pregnancies, glucose level, blood pressure, skin thickness, all continuous numerical values. And can you see it each or of in their different scale? So talking about this, consider this example. We are having an age column, a weight column and a length column. So when you talk about age column, the age values, right? So it starts here with 1-digit values, and it has 2-digit values. Maximum you can go with 2-digit nowadays. So if you have, you can have rarely a 3-digit value. That's it, fine. talking about weight. Okay, so if you talk about weight, you can have, if you are considering it in kilogram, then mostly it will be in a 2-digit. You cannot find a single digit. Okay, maybe for baby you can have it, and then you can have some 3-digit parts also here. Talking about length, mostly it will be after 100, so it will be more than 3, like in 3 digits, between a range of 100 to 200 it will be there, right? So like that, if you are having different columns, for example, if you have some other columns, they are going to be in different scale range. Okay, one may be in 1 digit, one will be in 2 digit, one will be in 5 digit, etc. But if you have this, and if you are passing this feature to your algorithm as such, then what your machine learning algorithm or model will do is, it will put bias on one feature which is like in larger scale. For example, here it may put a larger bias or a weight. Okay, talking about weight or bias, it's like giving more importance to just this column alone. So your prediction will be more dependent on this column and leaving these two columns, and it's actually not an important, like it's actually not a good task. Okay, you need to give a equal contribution from all the features, so that will be really good. And scaling helps to contribute all features equally. So in scaling, what we used to do is, we'll try to make them in a single scale, or we'll do some mathematical task which transform them into a range of values which are common for all the columns. Okay, so I hope you understand why we are going to scale the values, because of to avoid model to put weight on or importance on one particular column alone. Okay, talking about that, we have two methods, right? We have discussed about the types, which is normalization or standardization. Talking about normalization, it is a method of scaling the data by fitting the data points between a range of 0 to 1. Okay, for example, here in this normalization, we will be using this formula, this particular formula, and if I apply this formula, what will happen is, all your values will transform between a range of 0 to 1. Okay, for example, if I take this age column and apply this formula for all the points, okay, if I perform normalization here, then the minimum value of this column will be 0 and the maximum value will be 1, and remaining values will be between them. Okay, like that we can do for all the columns. So if I done that, you can have a range of 0 to 1 in all the columns, so their scale will be same and their importance can be given based on the values which they have between 0 to 1, right? So how they are achieving this, you don't worry, because you are not going to manually apply this formula. You can use this library. I'll tell you that before that, see here, for example, this is a univariate method, which means it consider only this column alone. Okay, if it's going to perform, then it will take consider of age column. If you pass this age column, it will take important parts like minimum value of that column, maximum value of that column. So consider this, we'll do on our own. Talking about age column, what is the minimum value? Which is 2. What is the maximum value? Which is 12. Okay, so now what I am doing is, the new value of x is going to be value of x minus minimum value of that column divided by maximum value of that column minus minimum value of that column. See here, for example, if I want to replace the value of 4, if I want to scale it, what will happen is, it will do for all the places, right? Talking about 4, x value will be 4 minus 2, the minimum value. In numerator we have 2, right? Below in denominator we will be having 10 minus 2, which will be 10. So now 2 divided by 10 will be, what will be the value for that? 0.2, right? So that 0.2 will be placed here. Okay, like that. So now it is inside a range of 0 to 1, right? But if you ask me, how are you particularly telling it will between 0 to 1? How it is achieved? Talking about that, consider, we'll find what is the lowest range. Okay, lowest range means for lowest value, which is 2. Okay, let us try to convert this old value. The new value of x is going to be 2 minus minimum value of that column. What is the minimum value here? 2. So 2 minus 2 will become 0. The entire thing becomes 0. So your new value is going to be 0. So here it will be replaced into 0. So your minimum value of that particular column now is 0. Okay. So if you go with 3, then what will happen? It will be 3 minus 2. Once again, it is not going to be 0. It will be around 0.01 or 0.1, etc. So you have escaped from that. Talking about the maximum value, 12 here, right? So 12 minus 2 will be 10. Below also it is 12 minus 2, which is going to be 10. So if you cancel out, your maximum value will be 1. So your maximum value is going to be 1 and the minimum value is going to be 0. So the rest of the values, if you calculate, it will be between that range of 0 to 1, and that is what happened in normalization. So if you convert this, you can convert this also with this weight column and length column. That is what happening in normalization. And to perform this, you can use from Sklearn. There is a module which is called, there's a package which is called as preprocessing. You can import min-max scalar. This is minimum maximum scalar, and here if you apply this is actually a class. So if you import it, you need to create an object. So I will be creating an object, and then with that object I will be calling methods or functions inside of it. I'll explain about the functions inside of it. So we'll go hands-on. We'll take diabetes dataset. I'll show you data.head. So we'll consider this, I think we can go with this blood pressure column. Okay, so we are having lot of numerical values. I'll go with dot min. So if you go with this dot min, then you can get what is the minimum value of that particular column which is available. So we are having 0, that is fine. And what is going to be the maximum value there? It is already 0, no issue. Maximum we are having 122, fine. So now what we are going to do is, I think actually blood pressure can't be 0. There is some issue with this data set. I think I'll load some other data set. We'll go with hard data set. Actually null places has been replaced as 0 in this diabetes data set, which is actually not good. We'll go with hard.csv for this example. We'll go with that cholesterol column. So the minimum value is 126 here, and the maximum value we are having is 564. Okay, so now what I'm going to do is, from sklearn dot preprocessing import min max scalar. See here the capital letters I am using in between, it is important. So I need to create an object which is I'll go with underscore scalar, which will be equal to this min max scalar. And it has functions like, if you call this object, you can use the methods inside. You can fit it. Fitting is learning. So if you need to pass it in a fit, you need to create a variable and fit it, and then you can call it once again to transform. So when you transform it, you will be getting your output or the transformed values. You can do it separately, okay, using transform also. Once you fit it, you have to go with transform, or else simply what you can do is you can do it in one step using fit underscore transform. So this is a method which will perform fit it and then transform the values also. So I am going to pass my cholesterol column here. So it will give you an array of values. So you need to pass it as a 2D also, that is important. Since you are passing single column, you need to pass like this. You will be getting an array which is converted values. So if you want to replace this in your cholesterol column, then what you can do is you can just call your cholesterol column, and the value is going to be the replaced fit underscore transformed value. So now if I go with the data.head, you can see the cholesterol column, the values range has been changed, right? Like that you can do for all the columns which are features and continuous values. Also I wish to show you the minimum value of that column right now. This is the minimum value of that column now. So if you go and check your maximum value of that column, that is around 1, somewhat around 1, right? So it is trying to achieve somewhat near to that, and you can see this is the minimum value we had, maximum value we had, and the remaining values are now is in this range, right? So you can also get the mean value. So this is how we used to use normalization. So they used to be between that range, right? Particular range, not above 0, or like it will be between 0 to 1. So if you do it for all the columns, then actually you can escape from that, okay, that scaling issue. And it's not only like this, you cannot it's not like you should have to go with only one column. You can pass your entire features alone, not with the target. If what all features you need to scale, you can combine and take them, send them inside. You will be getting a multi-dimension array. Then you want to create a data frame with that. I'll do that later. And yeah, so the next method is standardization. So there are different methods. I'll explain and I'll tell you also how or when to use it. Talking about standardization, this performs a statistical thing which converts all the data points to have a mean value of 0 and a standard deviation of 1. Mean value is the average value and standard deviation is the value how they are deviated from the mean value. So how it is achieved is, it is going to use a formula, okay. So the new value is going to be the old value minus mean value of that particular column divided by standard deviation of that particular column. So this will convert it to have a mean value of 0 and a standard deviation of 1. To achieve this, you need to use standard scalar, and you have to create a object for it, and then once again you can fit and then transform it later. So we'll try to do that. I'll reload this data once again. I'll let it be. So instead of this, what I'm going to do is I have now reloaded my cholesterol column, okay. So our task, you can see, is to go and get the cholesterol column's mean value and standard deviation now. It is 246 and .std will give you the standard deviation value, which is 51. Now what we are going to do is from Sklearn preprocessing import standard scalar. Is this scalar equal to standard scalar? And we'll go with data of cholesterol will be equal to ss underscore scalar dot fit underscore transform. We need to pass this cholesterol column as a 2D. That is done. So now if I go with data dot hit, the cholesterol column, it may even have negative values. It will be transformed in a way you can go and check. For example, if you check the mean value now, it should be around 0 somewhat. So this value, if you calculate it, it is like e to the power minus 18. It's actually very small value which is somewhat around 0. Okay, you can check it. And also if I go with the cholesterol column standard deviation now, and that is somewhat around 1, right? Little bit above, but it is somewhat around 1. So you can see from which range it has transformed, how the mean and standard deviation has transformed using when you use standard scalar. So now if you apply for all the columns like this, then you can actually avoid this issue. Okay, so I'll also show you before that we need to see another one. We have a third method also, which is robust scalar, which is robust to outliers. So what is outlier? This is what an outlier, can you see it? So you have rest of the points which are here, and you have one point which is not even relevant with the remaining data. So some data, if you have a group of together here, a lot of persons here, then they may actually a new range of values, but one person who is irrelevant with the remaining data, it's going to be an outlier. Here for example, if you are having 2, 3, 4, 5 etc. in 12, instead of 12 you are having 200, okay, 200 in the age. It is an outlier, right? Logically it's not possible, and once again it is irrelevant with the rest of the data points. And what if you are having 200 here, this one place alone is 200. For example, if you are applying normalization, what will happen? Your entire value is going to be changed because you are considering maximum value in all the places. So your maximum value now will be 200. Considering that if you calculate the value of 4, it is going to be 4 minus 2 divided by 200 minus 2. It will be 4 by 198. So the value of 4 will be very small now. Considering previously we had something around 0.2, now it will be very less. So like that, outlier will be hugely affecting your remaining set of points. Just this one point is going to be affecting everything, right? Similarly, if you go with standardization, then if you take mean value, once again that 120 is also going to be considered, sorry, the 200 will be considered. It will alter the mean value, it will alter the standard deviation, so your output will be altered. So that is actually a misleading one, so you need to be careful with that. In our steps, we will be learning about the outlier detection and handling also. So either you need to go through that and come for scaling, or if you want, you can proceed with this robust scaler, so which uses a quartile range. So it will take or consider the mean value or the middle value and the 25th and 75th percentile. We'll see about IQR when we see about outliers. So it will take only the range which are closer, and remaining the lower bound outlier and the upper bound, the range between that, the outside of things won't be given much importance here. And to use this, you can use from sclearn.preprocessing, you can import robust scaler, and you can fit and transform it like from sclearn.preprocessing, you can import robust scaler. And you can create an object and use it, the robust scaler also, if it is necessary. So yeah, so I'll also show you how to apply for everything. For example, data.head. So we are having this, right? For example, let us split now. In X, I need only the features, so I'll drop, okay, the target column, and the axis will be 1. I'm not going to use in place because I just need to have it in X. So now in X, we'll be having the features, and in Y, I'll call data.target. So now Y will be the output column and X will be the features, right? Fine. So now if we want to use scaling in all the places, then what I can do is, we have SS underscore scalar, right? So scale equal to X dot SS underscore scalar dot fit underscore transform X. So you can see the scaled value. It will be a multi-dimensional array. If you go and check the shape of it, you will be having all the rows and columns. Same 1025 rows and 13 columns are now in the array format. Okay, so I can even show you that the values are now converted. But if you want to change it into a data frame, once again in X, I'll call pd.dataframe and I'll pass the scaled value. And also the columns is going to be, to get the column names, you can call your previous X dot columns. So now if I go with X dot head, all the values will be scaled, which will be having a mean value of 0 and standard deviation of 1. And once again, you are not going to supposed to do like everything like this, because when you talk about other columns which are categorical, see here what and all categorical, you can see this rest ECG is having either 1 or 0, or this gender which is going to be either 1 or 0, mentioning male or female. It's not going to be like, even though if you scale it or not, there are two values, 0 or 1 or 0, 1, 2, 3, like that you will be having categories. If you scale it, then you will be having once again a set of values, like for example, if you go and call this column and go with dot unique, only two values is going to be there, they will be scaled. Okay, so now sorry, this is data. Now if I go with X, instead of 1 and 0, we'll be having only two values which represent them. But it's not actually a good task. Let it be 1 and 0, and let us convert the continuous values alone into scaled values for further proceeding. And talking about which is better, when to use it, when you go for normalization, it is useful when the data doesn't follow Gaussian distribution. Gaussian distribution is like you will be having a mean value of 0 and a standard deviation of 1. That will be coming under a Gaussian or normal distribution, not about the standard deviation 1. Actually, it will look like a bell-shaped curve. You can examine it. We'll be discussing a later part about Gaussian distribution, etc. So it is also, you need to, if your data is not in the shape of a bell-shaped curve, if you plot and see it, then you can proceed with normalization. or it is useful in algorithms when we go for KNN or neural networks. You can use it. Talking about standardization, when your data follows Gaussian distribution, a bell-shaped curve, and if you achieve that, then you can go for standardization. And whenever you have outliers, either handle it or go with a robust scaler. And that's all about scaling, feature scaling, etc. So moving with the next one, which is encoding. Talking about encoding, so as we discussed earlier, machine learning models can only work with numerical values. For this reason, it is actually necessary to transform the categorical values into relevant numerical ones, and this process is called as feature encoding. And here, instead of in the gender, instead of we are having male and female, they have represented it as 0 and 1, right? So like that, encoding will be happening. I'll tell you, there are types also. Talking about the types of encoding, you have nominal encoding and ordinal encoding. So if you represent the data without any order or hierarchy evenly, then it is called as nominal encoding, and you can achieve it with the help of one hot encoder. Or if you go with ordinal encoding, which is assigning unique integer based on the rank or order, it can also be done with label encoder. These two will comes from Sklearn. So talking about this one hot encoder, so it will assign without any order or hierarchy, just ones and zeros. Okay, so if you have a column of color which is red, blue and green, or the unique values, for each unique one you will be getting a new column now. And if you have one there, which means that is the answer, which is red, and the remaining will be 0. See here, if you have blue, then blue will have 1, the remaining will be 0. If you have green, so like that, if you have this categories, if you want to encode, if you go with one hot encoder from scikit-learn.preprocessing, then it will actually provide how many number of unique values, that many number of columns will be created. We'll try to do it. We'll take a data set which has categorical features and text. We'll try with Titanic dataset. I hope it is having some values which are categorical and text values. Okay, we have embarked, right? So it is actually a station. If you go and check it about data of embark, so if you visit the Kaggle website and visit about the column details, it is actually the station they have embedded. It's like Southampton, Cherbourg and another place. Okay, so dot unique will give you 3 different values, and you can also go with the data of embark dot value underscore counts. And you also have some null values, right? So we'll first drop it. So now we have these 3 distinct ones. These 3 are stations. So what we are going to do is we can use one hot encoder from sklearn.preprocessing, import one hot encoder. Please be careful with the capital letter and small letters to avoid errors, otherwise we will be missing it. Okay, OH encoder equal to, we need to create an object here also. You can directly transform it like we used to do in the rest of the scaling techniques. You can do it. So what we'll be doing is we can pass your values here. So first let us try O underscore encoder dot fit underscore transform, and here we'll pass our embarked column. Okay, dot to array, and I have converted it into an array. Okay, so you can see one, okay, in the first place. So let us go and get our column actually. Okay, C is given here in the first column like this. Okay, C, then we are having the rest of the columns, and you can see wherever we are having C, then it will have 1. Okay, what you can do is you can just combine this into the data frame. You know how to add an array to a data frame, right? You can create columns and then you can add this to your data frame near to this, so that embarked will be having 3 different columns. One will be S, one will be C, one will be Q, and these 3 will be having ones and zeros, and it will represent which is which. Okay, so this is one of the type, which is one hot encoding. You also have something like label encoder, which is like for male and female we have given 1 and 0, right? For example, if you have the team names, which is A, B and C, then A can be given 0. It's like they won't carry any information, any number. Obviously it is going to be category, so you can even give by rank, that's optional. For example, if A team is an important team, then you can go and give something like A will be having 1 or highest number or lowest number, like that. So 0, 1, 2 can also be given like this. So that's how we will be doing with label encoder. So same thing, you can import label encoder from sklearn.preprocessing. So how many distinct things will be there? Numerical values will be represented to represent that. So I'll import from sklearn.preprocessing, import label encoder equal to label encoder. So yeah, so what we are going to do is label encoder dot fit underscore transform data of embarked. Okay, so we are getting an array which is having 0, 1 and 2. Can you see it? So what you can do is you can call data of embarked is equal to. So now if I go with data.head, you can see now it has been replaced numerically. Instead of SC and Q, we have 0, 1 and 2. You can also get the count actually, data of embarked dot value underscore counts, and this will give us which is like 2, 1, 1, 16. We know this, right? S is given 2, then C is given 0 and Q is given 1. So it's actually in 2 place only. So like that we will be doing encoding. So like that, if you want to proceed like gender column, you will be replacing with 0 or 1 manually. You can do with pandas by mapping it, or you can just do like this, which is very easy. So that's how we'll convert our text values into numerical format for our machine learning. So in today's session, we have actually seen about scaling and encoding. So we will be seeing about imputing null values using algorithms in Sklearn, and outlier detection and handling in further sessions. Thank you.